Well, I'd like to start things off today by thanking you for taking the time to attend this presentation. My name is Lance Zurich, and today we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting what we would call a project-based class, and that's where students will be required to design and build a series of original prototypes based upon their own research and activities. And each of these sets includes standards-focused curriculum created especially for Studica by noted educator and STEM expert Tom White. So let's see. There we go. So today we're going to start off where so many technology-focused presentations for education seem to start off these days, and that's with discussing the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for more STEM education in the schools, STEM, of course, being the acronym that stands for science, technology, engineering, and mathematics, when you hear someone saying this, what they're essentially talking about is that there's an urgent need to prepare our students with the background that they're going to need to successfully compete in the job market that they're going to be graduating into. Now, in the employment market that once greeted our grandparents or even our parents, a good work ethic, a strong back, and being able to take direction on the fly might have been enough to land a good paying job where many of the technical aspects could be learned along the way. But now students must be prepared to enter a world that is increasingly focused on areas like programming, automation, IoT, and all sorts of rapid advances in technology. So because of this, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. And this is, of course, why so much of the emphasis in education over the last decade or so has been on developing STEM skills. Every new advantage that we enjoy, things like the tablets and the smartphones that we all use daily, were, of course, created because of individuals who helped to make those advances. Now, even right now, countries all around the globe, like China and India and so many others, are making major strides in developing new technological advances, and they're busy preparing their own students to take their place in the future workforce. But here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that are going to enable them not only to secure jobs, but also to be part of this next wave of advancements that we require to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, we're going to move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, the science of robotics, the Internet of Things, and computer science. All, of course, extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. But just how prized are they? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they do need to start developing these habits and the career focus as early on as possible, in high school, if not even in middle school. Now, the dilemma for educators, and it's whether you're in the classroom or the homeschool environment, is, of course, finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process and not just memorizing obscure facts or ideas to take a few tests, then promptly forget them. No, what you need to do is to be able to help students to be successful and to really encourage them to consider pursuing further education in subject areas like this. Educators need to be able to present the material in a way that makes it relevant. And that means answering the eternal question that students have, which is, why do we need to know this? And it also needs to be engaging. And that means being able to hold a student's attention better than all the rote notebooks and lecture presentations and videos that we have now. Something that has real world applications and where the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics program. These two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is intended to essentially be a standalone class dedicated to the subject. These were each created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that's relevant, engaging, realistic, hands-on, and again, which is crafted to meet the current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, again created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards which are currently in place in the United States. The curriculum is also designed for offering a project-based learning program, which I touched on before, and this again means that solving the problems that arise in each of the units requires the students to be actively involved in the research phases, the design, the trial and error experimentation and activities, and also in the building of actual working prototypes that will provide the required answers. And students aren't going to be asked to do this alone. They're instead going to be asked to work in small groups or teams of 4 students each. And this will help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And one, of course, when we're talking about things like soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some programming software, which we're going to discuss later, each set includes all of the physical building materials that the group is going to need to enable it to address all of the design projects presented throughout the course of the curriculum. The curriculum is designed to enable teachers of all sorts of backgrounds, even teachers who come from non-science and non-technology focused disciplines. It's designed to enable them to have all the information they need at hand, prepare them to conduct the class activities, and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system they're going to use to address the projects that are presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams. Again, these are teams of 4 students per group to create the solution. The project units each contain embedded academics. And at the end of each unit, students will be required to make a formal presentation of their prototype that they've created to address this particular real-world style scenario that's given. And they have to explain the reasoning behind why they constructed the prototype the way they did and why they made the choices they did. There's a technical literacy task driven by each of these projects. Now, as they work to address each of these projects, students are going to be acquiring the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are all acquired through the carefully designed enabling activities. And again, as required by each project, students will be asked to create original prototypes. They're going to, of course, also have to create any required programming-based solutions. And they're also going to be asked to maintain detailed documentation during the entire process. Now, as I've already touched on a few times in this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. Tom's a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for use in both educational institutions as well as for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology, for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted academic standards that are currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K to 12 and the standards for technological literacy. As I mentioned earlier, the programs are designed to be project-based. Now, when students ask a question like, why do we need to know this? Of course, it's usually because the subject matter that they're being presented with might come across as too abstract to ever be useful in their lives. But with this project-based approach, students get to see firsthand and understand why these things are necessary and where they're useful. The concept of working in these small groups to solve the project problems also, again, helps students to develop the high-demand soft skills that employers look for. And these are, again, skills like communication, analytical skills, quantitative skills, flexibility, adaptability, problem solving, and the list goes on. Now, in this project-based format, all of the subject matter is integrated. And what I mean by that is the math is integrated with the reading and the writing and so on. And this kind of format is really ideal for STEM education. And also because of the manner in which students must approach each of the projects being put forth in the curriculum. And again, this is with the research and the testing and the group give and take, just to provide a couple of examples. Because of this, it allows for a much deeper exploration of problems than traditional teaching methods might normally allow. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in the types of prototypes and solutions that are being offered. Now, the reason for this can be because of creativity or differences in the research or approaches taken by each group. But in any case, what you get out of this and what students will get out of this is they can see firsthand that problems can have many different answers, and that often there is not only one right solution for things. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and the knowledge they're going to need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that, again, is utilized in the design phases, the prototyping, the testing, evaluation, and redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. And again, this team approach is designed to help promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. And what I mean by that is you can just divide the number of students in your classroom by 4 to help determine the number of sets needed for each class. And again, everything you need to conduct this program, with the exception of the programming software, which I'll tell you about how to get that at the end, everything else is included right inside of the box. Access to the free curriculum download is included with the purchase of each set. And also included are all of the building materials which students are going to use in the creation of these prototypes. And in this case, the materials that they're using for this are all drawn from the unique Fisher Technic building system. And among the components that are included in each of these sets are 2 robotic controllers and 2 power supplies. Now, of course, as many of you may not be familiar with the Fisher Technic system, let me just give you a little bit of background here. Fisher Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed primarily to stack, the Fisher Technic system was created with more of an engineering mindset. And what I mean by that is, as you'll see on the screen, the core building block in the Fisher Technic system is unique because it allows attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place, and they use a tongue and groove assembly method. And the system itself also includes a wide selection of very specific parts, and these will be variations on gears, girders, sensors, and much more. And because of this, it allows technical builders to address equally specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, noted for countless innovations used in the construction and the automotive industries. Now, Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, Mr. Fisher was the inventor of synchronized flash photography, that was back in 1949, and he's also credited as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all used them in our homes. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing. And they're also known for providing consulting services to those who are interested in learning about automated processes. Now, with all of that being said, let's actually begin looking at these two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who may like acronyms, you can refer to it as SIM. The set is designed to help provide a well-rounded introduction to the core concepts behind mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, again written by Tom White. The curriculum contains enough activity materials to fill approximately 45 academic hours. And because of this, we recommend this program set for insertion into regular related class activities for use as a short class unto itself, or for after-school program use, or of course, for homeschool use. The curriculum created for the sets are this set is standards focused. Again, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle school or high school classes, or again, for addressing these same grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, so this is going to include everything from gears and wheels and axles. You're going to have blocks, you're going to have sensors, you're going to have all sorts of great parts, as well as 2 robotic controllers and 2 power supplies. Now, only the required robotic control software, which again we're going to discuss later, it's a download, is not included, but everything else is available right inside the box. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the following topic areas that will come up during the course of the curriculum. Things like sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital phototransistor, working with open loop and closed loop programming, working with digital branching, learning about analog sensors such as the photocell LDR, working with analog branching, and then also working with analog sensors such as the MTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum itself, we're first going to look at what's covered by the second set. The second set is titled the Studica Teaching Applications of Mechatronics Program, and this one, if you want to use the same acronym that we talked about before, you could refer to this one as STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. This set comes with access to a free downloadable 400+ page curriculum document, this time entitled Mechatronic Applications, also by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, are designed to fill approximately 180 academic hours. So essentially, you're looking at covering 4 times the amount of academic hours as were covered by the previous set. With this in mind, you really want to think of this set as a more expansive version of the material being touched on in the other set. And this is really designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day for 5 days a week or the equivalent for a full academic year. That's how much material you're going to have here. Now, again, this set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school, high school, or again, for addressing similar grade levels in a homeschooling setting. The materials in this set will include a selection of over 1,200 Fisher Technic building components. And once again, this is an array of gears, blocks, sensors, axles, and many, many other parts. And again, 2 robotic controllers and 2 power supplies. Of course, the software was required. It's a download. We're going to talk about that in a little bit. Now, there are twice as many project units included in the Studica teaching applications of Mechatronics program set as there were in the set that we previously discussed. This includes units on sketching and documentation, simple machines, mechanical systems, basic electricity, and then also project units focusing on the creation of a garage door, an elevator control, an automatic pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, there are links that will be provided to tutorial sections and activity materials for students to utilize to give them more background on things that they need to know right then. And this will include sections on sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming and digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, learning how to record positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and also working with data. So now that we've had a look at how each of these sets differs and what they share in the specific subject matter that's being covered by each of them, what we're going to do now is we're going to take a look at exactly how the curriculum itself is structured, because I think that'll be useful. Now, both versions of the curriculum do share the same format when it comes to the structure of how the units are addressed. And as already discussed, each version will include tutorial materials, activity materials, standards, and again, supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. And when I say that, what do I mean? Well, each unit is designed to very clearly spell out everything that's going to be addressed. And again, it's designed to provide the tutorials and the other information that's going to be required as the need arises. And this was done specifically to enable teachers from all kinds of backgrounds. And again, this includes teachers who come from a non-science or non-tech focused background, as we know often happens with STEM and robotic programs. Well, this is designed to enable those teachers to quickly become comfortable with delivering the material simply by reviewing each section before they present it in class. Every unit presented in the curriculum for each of these sets includes the following sections: an introduction, a discussion of the purpose of the project, the concepts being addressed or talked about, there's an outline provided, all the standards are spelled out, there are assessment rubrics that are provided, there's a discussion of the essential question and the student scenario, that real world style scenario. There's a daily plan, a roadmap for everything. And then there are also vocabulary words, and there are other resources that are provided. So now let's look at those a little bit more in depth. So each unit starts with an introductory section and again, the purpose of the project. And just as you would likely gather from that, this is the section that provides a brief description of the topic that's going to be explored in the coming days and the activities. And there's also a section that seeks to clearly spell out to the students why they're learning this material and why it's important for them to know. The next section focuses on the main concepts to be addressed in the coming unit. And these are the broad ideas that are going to be explored in the unit and the core information that students should take from this project that's going to be essential for them to understand and utilize, not only today, but to draw upon as they move forward in STEM-related fields of study, and of course, if they choose to pursue it, in STEM-related careers. following this, we have encounter the outline. And the outline, what we do here is we essentially drill down more specifically to what's going to be addressed in the unit. For example, as you're shown on the screen right now, this is taken from a unit that addresses different aspects of programming. So because of this, you see that we touch upon areas such as the methods for writing programs, which will be things like flow charts or word problems or what have you. We're going to get into program characteristics, for example, open loop or closed loop. We're going to get into branching, digital, analog, subprograms, and so on. Now, the next section of each project unit focuses on the specific academic standards that are going to be addressed in that unit. And again, as you will see, this includes the college and career readiness math standards, the reading standards for literacy in history and social studies, the writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for K-12, and the standards for technological literacy. Each project unit also contains rubrics, and these are going to include both the rubrics for the specific project area being covered, as well as general rubrics for literary tasks. Next up, we encounter the essential question, and this can be thought of as the big picture question that's going to be focused on the smaller individual activities, and of course, all of the aspects of the larger project which students are going to be asked to complete in this section. After that is the student scenario, and this is where the specifics of the project to be addressed are finally spelled out. And again, this is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of a device or a machine or a mechanism or what have you. Now, as I mentioned before, students are not asked to do this alone. They're going to instead work together in small teams to craft their answer to this particular challenge. Now, solving the problem will require each team of students to design a unique and original answer, usually a prototype, which once again will usually be in the, some sort of machine or what have you, along with whatever programming may be required. Now, just to provide an example, if you look closely at the student scenario that I'm sharing on the screen right now, you will see that the project in this unit has each group of students taking on the role of a design team employed by a firm that manufactures garage door openers. So they're members of this design team. And in this case, students are being required to design a specific type of control system for creating a new line of garage doors. The manufacturer's requirements are all spelled out, such as in the case of this example, they want the use of limit switches. They want to be able to meet certain safety codes that require a method for sensing if anything's in the way of a closing door, which makes sense. And they also need the incorporation of an automatic light. Now, again, each team of students will be tasked with creating both a unique and an original prototype. And of course, in this case, that's the garage door opening system. And they also have to create whatever programming is needed to control the prototype. Now, as they move through the challenge being put forth in this scenario, each student team will be required to document the entire process in both a design notebook and also a digital engineering journal. And this means noting all of the research, noting any trial and error experiments that they perform, and keeping copies of all design sketches and revisions that they create. And anything else that applies to this, they keep that as well. And at the end of each project unit, each team of students will be required to make a formal presentation in front of the class, during which they're going to be asked to demonstrate their prototype and the programming, if it includes programming, to demonstrate these in action, much as they would be required to do for an actual employer or client if they were in the real world. After that, the next section we encounter is the daily plan. And this is the section that spells out clearly, both for students and teachers, what's going to be expected of students, how the teacher is going to conduct the day's class activities, and what specific subject matter is going to be covered. Now, some days that you look at may involve discussions. Other days may be more research oriented, or sometimes just building small projects that help provide the building blocks that students are going to draw on to complete the larger projects being described in the student scenario. But in short, you can think of this daily plan as a roadmap designed to keep everyone on the same path. Now, you will see too that along the way, as different aspects are addressed in each day's activities, such as, for example, what's required in a design notebook, or how do you use the control software, how do you work with the controller or with flowcharts or what have you. But as these various things come up, there are also links to sections which provide further instructions and information on each of these areas. Now, at the completion of each unit, after the last day of the daily plan, is also a section containing vocabulary. And these are, of course, important words and terminology introduced during the project unit. And there's also a selection of useful resource materials. Now, these resources can contain a mix of different types of material, from carefully vetted websites and video links to PDF documents, PowerPoints, and other things as they might arise. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this is going to include information on how the parts fit together using the pin and groove assembly method, how to identify the different types of parts from the various types of girders and gears and blocks being used, the different types of axles, rivets, etc. And students are also going to get to build a very basic sample model that's going to help familiarize them with the system and how it works before they move on to the larger projects in each unit. And as learning and maintaining proper documentation is one of the areas stressed in this course of this curriculum, there's also a select section, which is this section, which details just what defines each type of documentation used on the screen. So what's required for a design brief, what's required for an engineering notebook. That's all spelled out so students learn how to do that properly. And as the process of conducting these types of more open project-based class activities can be new to many teachers, there's also a section that discusses specifically project-based STEM education and its benefits. Now, as that more or less completes an overview of these two sets, I'm going to quickly review the contents and purpose of each set, but this time with pricing. First, we have the Studica Introduction to Mechatronics Program set, which is, again, designed as a standards-focused project-based introduction to the core concepts of mechatronics. Once again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity material to fill approximately 45 academic hours. It's again designed for those educators who wish to offer a shorter form class on this material, to use it for after-school programs, or of course, for homeschool use. The teaching materials designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these particular grade levels. And the physical materials in this set include a selection of over 700 components. And again, this is going to include different blocks, gears, sensors, and much more, all taken from the Fisher Technic building system, which will also include 2 robotic control units and power supplies. These materials will again be used to construct the mechanical prototypes addressed in each project unit of the curriculum. Again, each set is designed for use by a team of 4 students, with pricing starting at just $699 for a single set, and discount classroom pricing for groups of 20 students or up is available by quote upon request. For the next set, the Studica Teaching Application of Mechatronics Program set, this is again designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, all based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, again written by noted STEM expert Tom White. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. Because of this, it's again designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent, to this subject for a full academic year. The set is designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic system. Again, blocks, girders, gears, sensors, axles, rivets, and much more, as well as 2 robotic control units and 2 power supplies. Once again, each set is designed for use by teams of 4 students, with pricing for a single set starting at only $799 per set, and discount classroom pricing for 20 students or more is available by quote upon request. Now, as I mentioned the software several times during this presentation, let me address that real quick as well. The software being used with these sets is Fisher-Technic Robo Pro software, which is a graphic programming software. What that means is it uses a flowchart style design using various icons, which students arrange and link to create programs that are used for each model. This type of software is ideal for teaching the fundamentals of programming to users of all levels. Now, it used to be that there was a cost associated with this software, but since we started doing this webinar, it is now available absolutely free and can be downloaded directly from the fishertechnic.de website. This is their German-based website, so you don't have to buy anything, you just basically have to download it. But do note that this is specifically for use with Windows 7, 8, or 10. This will not work with Chromebooks. So with that all being said, if you have any questions, this would be the time to use the question and answer window on the Zoom toolbar to type in any questions you might have. If I don't see anything pop up, I will look for any kind of activity. 1, 2, 3. So just to finish things up, if you're ready to take the next step, if you'd like to request a quote, if you'd like to speak to one of the dedicated educational representatives for your states, or any way you'd like to find out more about these sets or any of the other educational solutions we offer, you can simply call us toll free. Our number is 888-561-7521. Or if you prefer, you can email us at info@studica.com. Now, if you have any specific questions about anything that I've discussed today or something you don't think I covered as well, or you'd like to know more about, or if you'd like to know more about Fisher-Technic or any of the Fisher-Technic solutions that are available, you can also email me directly. My email address is Lance Zurek, that's Lance, Lance .Zurek, again, @studica.com. And I'm happy to answer any questions you might have about Fisher-Technic related items or the Studica Mechatronics program sets. So on that note, I'd like to again thank you very much for taking the time to attend today's presentation. We do look forward to hearing from you soon. Take care. Have a great afternoon.